we got going today? Okay. Today we're talking about geometric terms. Geometric terms is our topic. Okay. My essential question for today are: what are the key vocabulary words associated with geometry? Somebody needs to be writing this down. Okay. Geometric terms, the key vocab words associated or used in geometry. What are we trying to do? We're just trying to get an understanding of basic terms in geometry. Okay, that is our goal today. Right. And then the actual words that we're going to define today: angle, circle, perpendicular line, parallel line, line segment, point, line, distance, and plane. So it's going to be a lot of vocab for a lesson, okay? But we got to start somewhere. All right. Now, I know I get accused of this a lot, but there's a reason why we got our notes structured the way we do. I'm going to give everybody one more minute to write down what I got on the board. If you don't get it all written down, it's okay. I can go back at the end of the lesson and go back to this slide, and you can write it down then. Okay? So it's okay if you don't get all this written down at this exact moment. You feel like you're speed writing stuff down. Okay? But this is what we got to do to keep pace with everything. Okay? And then, as we define these things, using my notes, you can put them in the box underneath, right? You put some of those definitions down there, and I give you time on each slide to write stuff down. I try to make it pretty easy. Okay? About 15 seconds. Aye. If you didn't get it written down, it's okay. I'm going to come back to you in a little bit, okay? All right, here we go. First thing, a point. A point has no dimensions. It's located on a plane represented by a dot. Pretty easy, right? No dimensions. Located on a plane, we'll talk about a plane in a second, represented by a dot. Coach? Yes, sir. What can I name my point here? What's one of your favorite letters? U. Don't think I've ever used that one right off the bat. Cool. U. That's simple, right? That's elementary, my dear. Okay? That's about as simple as we can get. A point has no dimensions, represented by a dot. It's just a point or a location in a plane, on a plane. And y'all are going to be like, what's a plane? I told you. If something goes in the air, takes you from A to B, gets you there pretty fast, goes several hundred miles an hour, okay? No, that's not right either, geometrically. We'll get there, okay? All right, again, I can go back to this definition here in a little bit, okay? Next, a line. Okay? A line has one dimension. It's an infinite set of points represented by a line with two arrowheads that extend left end. Okay? A lot easier in geometry when you draw a picture. Okay? Coach's point, U, can be connected to another point, T, by a line. Check out what a line does. It connects those 2 points, and it extends beyond those points. Those arrows are really key. That, ladies and gentlemen, is a line. Can I have more than 1 point on this line? Yeah. How many points can I have on this line? As many as I want. As many as possible. Right? As many as possible. That's how many points I can have. Right? We'll test it. I can have this point, call it Q. I have this point, call it A. I can have this point, call it L. Okay? I can have a million of those points. I can have 2 points, right? As long as there are 2 points involved, I can have a line. Okay? Any questions about that so far? Pretty straightforward, right? Y'all like, man, this is like real easy. Right? I hope y'all see that. Okay, I'm gonna move on now. A plane. Woo! A plane has 2 dimensions, extending without end. Watch very carefully how I draw this. Okay? Y'all don't want to draw what I draw. Plane's got 2 dimensions. Really and truthfully, it's just a bunch of lines that intersect. Okay? That's really what a plane is. Bunch of lines that intersect form planes. Okay? 2 dimensions. We'll learn throughout this course. That's a very key transition from a line to a plane. Okay? Planes is what's going to give us shapes. Plane is what is going to give us volume, gives area to a figure. Bonus question. How many points can there be in this plane? Infinite, right? An infinite number. Okay? Triple or double bonus question. Can a point be in the plane but not on a line? Yes. Very good. Okay? What am I on now? Triple bonus question. Okay? Triple bonus question. How many lines do I have drawn on this figure? How many? 4. Right? 4. Quadruple bonus question. Is it possible to have more than 4 lines in a plane? Yeah. Okay, y'all got me? So if I wanted to, I could sit here all day, draw line after line after line after line after line, and it would still be a plane. Okay? There's still only 2 dimensions to it, and you will define, you'll have in geometry, you'll have a definite plane. Okay? Again, those are things that we'll pick up on. Line segment, these are, if you want to know, my favorite. Okay? Nobody wanted to know, but it's okay. All right. Coach started off with a point. We called it U. I added another point, called it T. Correct? Then I drew what? What did I draw connecting those points? A line, right? And what did I say was real important that was on that line? Arrows. Notice how I draw a line segment. A line segment, which will look or symbolize like that, with no arrows on top of it, has 2 endpoints, and it includes all the points between them. Okay? So, we're going to do a quick little game here. Yes or no is the name of this game. I like it. Okay? Yes or no. Yes or no, the point that I'm going to draw is in or on the line segment UT. No, right? That's not on that line segment. Right? Because the only thing on line segment UT are all the points between U and T that's on the same line segment or line. Okay? Yes or no? Yes. Okay? That point is between points U and T, and it's on the same line segment, right? Okay. Now I'm going to get I'm going to tell you something very important. If you understand that principle, you're going to make it through about 70% of this course. Okay? Believe me, we're going to add a lot to that. Okay? But that's about 70%. That's the core basic concept of what we've got to do in here. All right? It is truly that simple. Okay? We're going to make it more complicated. We're going to add some layers to it by doing shapes and principles and theorems and all sorts of stuff. But that's kind of it. That's one of the key parts of this course. Okay? Array. Oh, good old rays. Okay? Array is almost like the combination of a line and a line segment. Now, there's probably some really good geometry teacher out there that would say that's not true, and he's probably right. But for our principles, what we're doing in here, we started with U, we added T. If you'll recall, we started with a line, right? Our line went through UT, had arrows on the end. Okay? Array has one endpoint and extends without end in one direction. Right? And it can go either way that you want it to. So, if I wanted to make ray UT, start at U, extend through point T and go beyond it, that's what I do right there, guys. That would be ray UT. I could go the other way as well if I wanted to. I could start at T, go back to U, and go through U, okay? But do you see how this is kind of like where a line and a line segment come together, right? But you have a definite beginning right there, correct? Definite beginning. When the things you're going to get asked on a quiz is something like this. Okay? It's going to say, if you start at U, if I start at U and I go that way to T, is point D on ray UT? The answer is no. Even though it could be on this line, right? I got to think of it like this. The only things that I consider on ray UT is whatever's from point U to T and beyond. Okay? Got me? This will make more sense the more we do it. If, using this same diagram though, I said, what about point A? Would point A be on ray UT? Yes, because if I start at point U, go to point T, and then go beyond, point A is on that particular beyond section of the ray. See that? Okay? All right. Those are core principles, again, that we're going to talk about. Here's a good one. This one's not necessarily something that we're going to do right now, okay? But it is important. Parallel lines. Parallel lines are lines that don't intersect and are coplanar. Coplanar. There's a key word in there. Coplanar. That you need to make sure you know. Coplanar. What word do you think it is? Good. After 4 times, we picked up on that, right? Coplanar. Anybody got an idea what they think that means? What's that? Not 2 planes. That's biplanar. Maybe. I don't know. I made it up. Coplanar. Co means what? Is that? No. I means 2. Co means the same or together, right? Within the same, right? We're co-workers, right? We work together in the same job, right? You got me? Co, that word co, that prefix, co, means together or within, okay? So this is within, right? Within the same plane. Within the same plane. I won't go over this too much right now, but parallel lines are always equidistant between them. In other words, if that was 5 feet right there, if I extended this to Utah, okay, they're still coplanar, and they're still 5 feet from each other over in Utah. You got me? Okay, that would be the true definition of coplanar parallel line. Right? Any questions so far? Go back. Go down back. If you extend to the back, it's okay. I got plenty of them. Okay. Next, one of my favorites again. Perpendicular lines. 2 lines that intersect to form a right angle. Man, we didn't do angles today, so we don't quite know what that means, okay? But we'll do angles tomorrow. I'll talk about it a little bit more tomorrow. If 2 lines, well, what does it say? What does intersect mean? They cross paths, right? Y'all ever heard of a wreck in an intersection? Right? That's where 2 roads come together, cross paths, okay? Here are 2 lines that intersect. Now, there's a trick question I'm going to ask. Are those perpendicular lines as it sits right now? If you said yes and I didn't say no, okay, not right yet. I'm missing something from the definition. What am I missing? Right angle. Not until I do this, Does that mean it's a right angle? I know something's a right angle because it's got the box. Okay, there's the box involved. That tells me it's a right angle. Right? What's that now? We need to get into our heads that it's not. Okay? Got me? We need to get that through our heads right now. When I see the intersection in that box, I know it's perpendicular. When I see the intersection and it looks like it's really close, but I don't have the box, not perpendicular, not yet. Okay? I can prove, there's certain things I can do to prove that they are perpendicular, but you're getting to about third, fourth week of September, maybe first or second week of October, and I'm on the thing there yet. Okay? All right? Here we go. This got to be one of the last ones, I think. So I know I bored some of you to death, but oh well. Okay? An angle. When two lines or line segments meet at a point. I don't know, that kind of brings a lot of stuff together, doesn't it? Okay? All right, let's go back to what we started with today. Professor Cook said he wanted point U. I wanted point T. Oops, sorry. I wanted point T. All well and good. We could make them a line segment. We could make them a line. Either way, right? Y'all with me? Okay. Then, Jada, what's another point you like? It can be anything, any letter. What's your favorite letter? Let's make one up. C. Cool. You got point C? Okay, we'll do C as well. Okay, Z for zebra. If they intersect, what's your favorite letter? Okay, this is an interesting question. Anybody at R? Okay, thanks. Okay, let's say these two line segments intersect at point R. All right, I have just formed 1, 2, 3, 4 angles. Right? I've just formed 4 angles. Here's how I can name these angles. I can name this CRT. CRT. Here's how I represent an angle. It's like a little Pac-Man thing. Okay? Less than, greater than sign, right? Okay? This would be angle CRU. Angle CRU. This would be angle ZRU. Angle ZRU. And this is CRT. Angle ZRT. You'll notice what every single one of those 4 angles has in common. What is it? Letter R is in the middle. So point R is what we call the vertex of each of those angles. Okay? We call it the vertex. We'll talk a little bit more about that tomorrow. Finally, I think this is my last one. Let me double check. Yep. Finally, guys, I have a thing called a circle. I gave this to you today so that if I mention it between now and January, we know what it is, okay? Even though we probably aren't going to talk about them until January, at least I can say, hey, remember on the first day of the notes that I talked about it? And then you can say, yeah, I got it. No problem. Okay? A circle is strange, okay? Strange shape. Okay, all points in a plane that are equidistant from a given point called the center. Okay, well, I know what a point is. That's what Coach had earlier. He had U. Okay? And if I went, let's say, 5 feet out, equidistant in each direction from point U. All the points that connect that are equidistant, that are exactly 5 feet from point U, form what we call a circle. And if you're like me, you can draw perfect circles, just hand draw a perfect circle, just like I did. That's not really a perfect circle, but one of the things we will do in here is construct a circle, okay? And when you construct a circle geometrically, it's always perfect. By definition, that's what you're doing, right? I've bored most of you to death, but I appreciate your notes. I'm really impressed. Only Katie's fallen asleep so far, so that's really good. And, oh, just kidding, all right? If I have any questions about any of those terms, anything, yes, ma'am. Absolutely. Absolutely, I will. Okay, I'll go back to the first part. Guys, that's all the notes I've got so far for today. Okay, what I'd like for y'all to do now, let's see, 3, 2, 1, take a break. Okay, you got 6 minutes. Y'all can do whatever you like. If you don't mind turning the phone on, turn the lights on for me. We're at our halfway mark right now. I'm just going to